3.8, Creating Polynomial Functions Using the Fundamental Theorem of Algebra. Today we will write polynomial functions given the roots using the Fundamental Theorem of Algebra and the rules of conjugates. Example 1. Write the simplest polynomial function with the given zeros. So please take note, a function's degree equals its number of zeros. This is true for all polynomial functions. Zeros are not necessarily real. They may be complex numbers. So when we start, if we have x is equal to 4, we want to get all of these set equal to 0, so we're working with 3 factors. So the inverse of subtracting 4 is adding 4, so we have x plus 4. The inverse of subtracting 1 is x plus 1. The inverse of division is multiplication, so we have 3x. The inverse of a positive 1 is subtracting 1. Then we need to distribute all of these things out. So x times x gives us x squared, x times 1 gives us 1x, 4 times x gives us 4x, and 4 times 1 gives us 4. We combine our like terms and we have x squared plus 5x plus 4. We then need to multiply that trinomial by our other binomial. So I'm going to use a generic rectangle for that to keep my work nicely organized. I have 3 terms in my first, so we have an x squared, a positive 5x, a 4. I have 2 terms in my binomial, so I have a 3x, and I have a negative 1. I'm then going to multiply. X squared times 3x gives me 3x to the 3rd power. 5x times 3x gives me 15x squared. 4 times 3x gives me 12x. X squared times negative 1 gives me negative x squared. 5x times negative 1 gives me negative 5x. And 4 times negative 1 gives me negative 4. I'm then going to combine my like terms, and I have a polynomial function that equals 3x cubed plus 14x squared plus 7x minus 4. Example number 2, write the simplest polynomial function with the given roots. Please recall that irrational roots come in conjugate pairs. So if you have a plus the square root of b, you also must have a minus the square root of b. So we have a positive root 3. We also need to add a negative root 3 to our problem. So when we use our inverse operations to turn these into factors and get them set equal to 0, we have x plus 1, x minus 5, x minus square root of 3, and x plus the square root of 3. I'm going to distribute my first 2 binomials together, so I get x squared minus 5x plus 1x minus 5. Combine my like terms, I get x squared minus 4x minus 5. When I combine my factors with radicals in them, I get x squared, I get plus square root of 3x minus square root of 3x minus the square root of 9. When I combine my like terms, I get x squared. My root, positive and negative root 3x cancel out. Square root of 9 is 3, so I get x squared minus 3. I then can make a generic rectangle to distribute these out. X squared, negative 4x, negative 5, x squared, negative 3. I'm going to multiply to see what goes in the box. X to the 4th, negative 4x cubed, negative 5x squared, negative 3x squared, positive 12x, and positive 15. Combine your like terms to write your simplest polynomial function. We have x to the 4th minus 4x to the third, negative 3x squared minus 5 more x squareds is negative 8x squared plus 12x plus 15, and we are finished. Example number 3, write the simplest polynomial function with the given roots. So please recall, when we have complex roots, they also come in conjugate pairs. So if we have a plus bi, we have to have an a minus bi. So in example 3, we have x equals negative 3, which we can write as a factor x plus 3. And we have x equals 2 plus I. So we need our conjugate pair, so we also have to have x equals 2 minus I. So if we write that together, x equals 2 plus or minus I, we would subtract our 2, so we have x minus 2 equals plus or minus I. Well, I remember that I squared equals negative 1, so if I square both sides, I would have x minus 2 times x minus 2 is equal to negative 1. I then can distribute my left-hand side out, x squared minus 4x plus 4 equals negative 1. Add my negative 1, so I get x squared minus 4x plus 5 is one of the trinomials I'm working with, and I need to multiply that with my x plus 3. So you can distribute, or you can use a generic rectangle, whichever method you prefer. Generic rectangle saves me some space, and I make sure that I distribute everything from one parenthesis to the other. So I get x cubed minus 4x squared positive 5x, 3x squared, negative 12x, 15. So when I combine my like terms, I get a polynomial function that is x cubed minus x squared minus 7x plus 15. On example B, please recall that irrational roots come in conjugate pairs also. So if we have a plus the square root of b, we have to absolutely have a minus the square root of b. So we can do this the same way by adding a little plus sign here. When we have I, remember that we have to have a plus or minus I. So if I square my positive or negative I, if I square both sides of my equations, I know that x squared is equal to negative 1. When I add my 1, I get x squared plus 1 as one of my factors. When I subtract my 1, using inverses, I have positive or negative square root of 2. I then, to undo a radical, or a square root, I can square both sides. So x minus 1 times x minus 1 equals 2. Distribute this out so you get x squared minus 2x plus 1 equals 2. Use your inverse operations. So you get x squared minus 2x minus 1. You then can use a generic rectangle to distribute those back out. X squared minus 2x minus 1 times x squared plus 1. Multiply negative 2x to the third, negative x squared, negative 1, negative 2x, x squared. Combined your like terms, so we get a polynomial function of x to the fourth minus 2x cubed minus 2x minus 1. Example number 4, write the polynomial function for a specific y-intercept. So the first thing that we need to take a look at is that we have zeros at negative 2, 3, and 5. So if we write x equals negative 2, x equals 3 and x equals 5, we have the factors x plus 2, x minus 3, and x minus 5. When we distribute our first two out, we get x squared minus 3x plus 2x minus 6. Combine your like terms and you get x squared minus 1x minus 6. You then need to multiply that with your other binomial, x minus 5. So when you distribute that out, we get x cubed minus x squared minus 6x. Distribute the 5, we get negative 5x squared, positive 5x, and positive 30. When we combined our like terms, we get f of x is equal to x cubed minus 6x squared minus 1x plus 30. When we have the standard form, we have f of x is equal to a times our polynomial, x cubed minus 6x squared minus 1x plus 30. And we need to solve for a in order to make sure that it goes through our y-intercept of 10. So we're going to replace our y with 10. And we're going to replace all of our x's with 0 because the y-intercept is the ordered pair 0, 10 in order to solve for a. So when we cube 0, it's 0. When we square 0, it's 0. 0 times negative 6 is 0. 0 times negative 1 is 0. So we're left with a times 30 is equal to 10. Divide by our 30, and we get a is equal to 1/3. So when we rewrite this polynomial function for the specific y-intercept of 10, we're going to place our 1/3 in front of the polynomial we got from distributing our zeros, x cubed minus 6x squared minus 1x plus 30, and we just wrote a specific polynomial function for the y-intercept of 10 with the given zeros, negative 2, 3, and 5.